Hi, I'm Lee Teschler with Machine Design Magazine. We're here with Steve Sharp from Avago Technologies, and we're going to talk a little bit about encoder technology. Well, Steve, I think most engineers know that Avago is pretty good with encoder module, but I don't think very many people know that you also put out housed encoders.
Avago's been making encoder components and modules for probably over 20 years. But we also make the complete housed or kit encoders for the customers that don't want to assemble them themselves.
There's several different kinds of encoder technologies. What kinds of housed encoders do you guys do?
Well, there's three major types, or actually the technology falls into three types of technology. First of all, there's optical reflective, optical transmissive, and also magnetic. And then we sort of group those into three categories: incremental encoders, absolute encoders, and panel mount.
Can you give us an example of something you do in incremental encoders?
Sure. Two of our most popular families in incremental encoders are the AEDS 8000 series and the HEDS 5500, 5600. And so I'll show you some examples of each. This little guy is an AEDS 8000. Now, it's a relatively small encoder. It's only 20 millimeters in diameter, so it can be used on a motor as small as 25 millimeters. It can go up to 500 counts per revolution and has an operating frequency of 200 kilohertz, so it can be used on small motors that are spinning as fast as 32,000 RPMs. We find it used a lot in equipment like wafer handlers or automated pick-and-place machines. It's also got built-in differential line drivers, so they can drive cables up to 4,000 feet long.
Can you give us another example?
Yeah, so the other most popular incremental encoder we make is the HEDS 5500, 5600. So here's one example with the bottom plate removed. You can see the pieces, and also with the bottom plate on it. Now, this family is our most versatile, and we have the most options available. You notice they're larger. If you remember that little 8000 series, these are used on motors typically over 40 millimeters in diameter, so they are physically larger. One of the advantages is you can get this in a whole range of resolution, from 50 counts per revolution all the way up to 1,024. So, and it also operates at 100 kilohertz, so it can handle motors that are running faster, where you don't need as much resolution, or motors that are turning slower, where you want a lot more fine gradation. Now, in fact, these two examples, one of them is a metal code wheel, and the other is a mylar code wheel. The metal ones obviously can handle higher temperature, but if you want to go up to 1,000 or 1,024 counts per revolution, you go to the mylar code wheel. It has much finer resolution capability. And then we also make it, in this version with the pigtail cable, is the line driver version. So that has the differential RS-422 line drivers right inside. And again, with line drivers, you can drive a 4,000-foot cable. And so the perfect applications for the HEDS 5500 and such are equipment such as stepper motors, manufacturing equipment, textile machines, things where you often have motors turning slower, but you need a lot of accuracy as you're positioning a conveyor or an arm or that type of equipment.
When you're talking about encoder modules, you have a lot of flexibility. What type of options do you have with housed encoders?
Well, with housed encoders, a lot of the options fall down into the broad categories of either resolution, temperature range, output format, whether it's line driver or not, or even mounting configuration. So here's another family. These are reflective encoders as opposed to transmissive. They are also incremental. This is the HEDR 5400 series. Now you notice one of these is just round, so it would be mounted directly to the bottom of the motor, potentially with adhesive, or it can be available with mounting ears. So if you had a large system, maybe not just a motor, but you want to mount this to the system, you can get it with mounting ears as well. Now, the 5400s are not quite as sophisticated as the 55, 5600s we looked at. So these are relatively low resolution. They only go up to 200 counts per revolution, and they're only rated at 15 kilohertz. So they're used in much slower operating equipment, but they're smaller and a lot less expensive than those other encoders we looked at before. So for something like a vending machine, where that little screw is not turning very fast, these are perfect.
You also have encoders that look like potentiometers. Can you tell us about those?
Well, yeah, before I go to the pots, I wanted to bring up another technology we have, This is the AEAT 6000. Now you notice this one doesn't have anything in it. You don't see a code wheel or anything to mount on the shaft. But this is a magnetic encoder. Now being magnetic, it's a little bit newer technology. It's sealed, so it's very impervious to any sort of environmental conditions like dust or moisture or contamination. In this case, this would mount over the motor, and on the end of the shaft would be affixed the magnet. Now, this version is actually an absolute version, so this has information directly upon power up. So if you've got a piece of equipment such as anywhere that you need absolute position of an arm or a motor, you don't want to wait for it to start turning, an absolute encoder is the way to go. Now the magnetic ones are also available incremental, but people use these where you have to know that position of that robotic arm immediately when power is turned off or turned on. You can't wait for it to start moving. Now you mentioned the ones that look like potentiometers. Now, you probably had some things like this in your equipment many years ago, right? Now these are digital rotary pulse generators. Now, the one you're turning there doesn't have any resistance, but if you were to take this one and try to turn it, it has little detents, kind of like I have on the knob on my car stereo. These are perfect anywhere you need to get digital information in relation to somebody turning a knob. So they're basically a replacement for that old carbon potentiometer, but they're digital pulse encoders, mount to the panel, get digital information, and you won't have to worry about the carbon wiper wearing out or getting dirty and scratchy anymore.
Thanks, Steve. That's a great overview. Viewers can get more information at the Avago website, www.avagotech.com/encoders.